This video is on the first of our measurement labs, the metric system, part 1. I'll start with a story. You all know the company Lockheed Martin. It's involved with aerospace, defense, security, and technology, and the United States government pays them billions of dollars. One of their contracts was between NASA and Lockheed's Space Systems division. Lockheed wrote software to help NASA control the 1998 Mars Climate Orbiter, a satellite that was going to go around Mars and measure Mars's climate. The Mars Climate Orbiter was a space probe launched at Mars, and after 286 days in space, as it approached Mars, there was a miscalculation in its thrusters. This pushed the ship too deep into the Martian atmosphere, where it broke up under the stress. It was lost. The miscalculation happened because Lockheed negligently used English units of force, which were pounds, instead of the metric units of force, which were newtons, that NASA was using. The cost of the mission was $327.6 million, all down the drain. This shows the importance of watching what units you use when you measure things. Part of science is quantifying the world. We quantify our observations. So we add numbers to them and units. These measurements allow us to make objective comparisons, share information, eliminate our bias, and reveal trends and truths about the world. We find patterns when we quantify things. Scientists measure physical quantities, such as the length, height, or width of things, the time it takes something to occur, mass and weight, volume, energy, or temperature. Measurements include a number, and they also need a unit. Saying that a patient is 3 is meaningless. There needs to be a unit attached to that number. 3 feet has meaning. 3 grams has meaning. There are 2 major systems of measurement used today. The United States customary system, also called the English or British system, is used by 3 countries: the United States, Liberia, and Myanmar. The rest of the world uses the metric system, also called the SI system for its French name, the Système International. So scientists and most of the world use the metric system because it's an easy thing to use. The names of the measurements are all standardized, and it is easy to convert between measurements because the difference between the units are based on the powers of 10. Everything is 1,000th or 100th or a 10th or 10 times bigger or 100 times bigger or 1,000 times bigger. The Old English system has units like pounds, ounces, feet, gallons, miles, and quarts, and so on, but it requires knowing many conversion factors. You have to know there's 3 feet in a yard or 4 cups in a quart. You have to know there's 12 feet in an inch. Whoops, I got that backwards. It's easy to see how these things can screw you up. You have to know there's 5,280 feet in a mile. But how many inches are in a mile? For that matter, how many miles are there in a unit of a parsec? What's a parsec even? The Old English system has strange units. If you're from Iowa and you grow corn, you know that grain is sold by the barrel, peck, bushel, or even something called a hogshead. Medicine was once taken in a unit called drams. These are all too confusing, and there are many different names for many different things. On the other hand, in the metric system, the units have 2 parts. There is a base unit to let you know what you're measuring. If you're measuring the length, width, depth, or height of something, you're working from the base unit of a meter. If you're measuring the volume, the 3-dimensional space that something takes up, you're using liters. And if you're measuring the mass, you're using a gram. You'll notice the base units have abbreviations or prefixes. M for meters, capital L for liters, and G for grams. Liters gets a capital L to prevent confusion with a lowercase l or the number 1 in a computer. They can look very similar. The other part of a metric measurement is a prefix. So beginning from the base unit, if we're measuring with units that are much bigger, like the way miles are bigger than feet, a kilometer is bigger than a meter, or the way an inch is smaller than a foot, in the same way a micrometer is smaller than a meter. So there are prefixes to let you know that we're using units bigger or smaller than the base unit. Here's a list of some common things that can be measured, the metric unit involved, the abbreviation for it, and how it would compare to the United States equivalent. You don't really have to memorize the United States equivalent. When we're converting from things, that information will be provided to you, but you have to know how to find it and how to use it. You'll see more as we go through converting from units of the metric system to the English system. Here is a chart showing the prefixes and the symbols or abbreviations for them, how it reflects how much bigger or smaller it is than the base unit. So there's no symbol for the base unit, you just have grams, meters, or liters. But if you wanted to measure something much bigger, you could add something 10 times, 100, 1,000 times bigger, or we could use units that are such as mega, giga, or tera. Luckily, the way computers have become so common, we understand kilobytes, megabytes, gigabytes, and terabytes now much more than we used to. So these symbols are more familiar to people because of technology. In the healthcare professions, you would much more commonly be using the smaller units. When we talk about medicine, it is often administered in microgram or milligram doses. So in healthcare, you're much more often working with the smaller units that reflect how to measure things that are much, much smaller. One other thing to note in the pattern of the prefixes, you'll see going from the base unit, the first 3 steps up and the first 3 steps down follow a pattern of just moving the decimal one place. Taking meters, for example, this is because a meter, being about a yard, is something that makes sense to people. If you say a person is 1.7 meters tall, people can understand how tall another person is. If you think in something like a decameter, a DAM, well, that's about the width of a street. Or a hectometer, something that's 100 meters long, that's about the length of a football field. We can easily imagine that just by looking around the world around us. Likewise, a kilometer or kilometer at 1,000 meters, we can imagine how far it takes to run a 5-kilometer race. That's about 3 miles. It's going to take us a little while. However, beyond those first 3 units, you'll see that things get bigger by a factor of 3, from 1,000 to 1,000,000 to 1,000,000,000 to 1,000,000,000,000. This is because the units start going beyond what we think of commonly in our day-to-day life. People don't live in a way where they can walk 1,000,000 meters or a megameter. That would involve walking around the earth. Or a billion meters is going to take us off into outer space. So to simplify things, scientists started going up by big chunks, and they didn't provide a name for every little movement of the decimal places. Likewise, going smaller, a millimeter is so tiny. It's the width of, a pencil line. Smaller than that, a micrometer, well, that's too small for our eyes to see. Same with a nanometer or a picometer. So since these extreme units are so far outside of the realm of our world, they started moving by 3 decimal places at a go. Some common conversions to know. A kilometer is 1,000 meters. The prefix kilo indicates something is 1,000 times bigger than the base unit of a meter. So it's useful for measuring long lengths. For example, the Earth's circumference is 40,075 kilometers. K for kilo, M for meter. A millimeter is equal to 0.001 meters. The prefix milli indicates a fraction of 1,000th the size of a base unit of a meter. This is useful for measuring small lengths, like a pencil tip is about a millimeter across. One final unit to get familiar with is a microgram. It's equal to a millionth of a gram. A gram is the weight of a paperclip or an aspirin. The prefix micro indicates the fraction of 1/1,000,000th the size of the base unit of a gram. Note, they had run out of uses for M. There was M for meter, M for milli, capital M for mega, so they used the Greek letter mu to symbolize micro. That's the weight of about 1 eyelash. Now, if you can think of these systems as 2 islands, the metric island has relatively straight lines, and it's easy to move from one unit to another. However, the English island has many strange conversions, and you have to know that there's 12 inches in a foot, and 5,280 feet in a mile, and 3 feet in a yard. And so it is hard to get from one place to another because of all the different conversions. Later, we'll see how to go from one thing to another. How do you go from inches to centimeters, or from yards to meters, for that matter? Those are things we'll do in a later lab. So this has been our introduction to the metric system. Thanks for watching. Answer the questions involved. I hope this helps. Bye.